Okay, good evening and welcome to our class again today. I believe you had a nice time. In this class, I will show you how to differentiate the function y equals to sine x raised to the power of cos x. All right, before we start this class, I would really like you to don't forget to subscribe to my YouTube channel. Make sure you thumb that subscription button and like and comment so that it will help us to upgrade our video the more. All right, all right. So let's make it fun. This is a function, right? Y equals to sine x raised to the power of cos x. For you to solve this problem, it may look simple to your eye, but it's not really simple like that. I felt this question once upon a time. Something you will not believe it. All right, so the first thing you do, like step one to solving this problem, is to introduce natural logarithm, like ln, introduce natural logarithm, like logarithm to base e, which is also known as ln, to both sides of that equation. Let's call that equation one. To both sides of the equation one. All right. So what I mean by that is ln y equals to ln sine x raised to the power of cos x. Remember this law? Laws of logarithms state that if you have log of, let's say, x raised to the power of y, it resolves into y log x base a, meaning that the exponent becomes a factor that multiplies the logarithm itself. So if I obey this law of logarithm, the expression to the right will become ln y equals cos x ln sine x. Okay. Now, the next step, let me call that step two, will be to differentiate implicitly. You will differentiate the function implicitly. Let's call this equation two. Differentiate equation two implicitly. And by so doing, you will have derivative, okay, with respect to x. Respect to x. So we do that, we have derivative with respect to x of ln y equals to the derivative with respect to x of the expression cos x ln sine x, close. So let's call this equation 2 or 3. So, and we continue. If you differentiate, let me write that expression again here. You have derivative with respect to x of ln y equals derivative with respect to x of the expression. What do we have in the expression there? We have cos x then sine x, cos x ln sine x. Okay. Now, to the left-hand side, we have a special logarithmic differentiation. Remember, if let's say a variable v equals to ln a, so if you differentiate v with respect to a, you will have 1 over a times the derivative of a by itself, that is 1. That will give us 1 over a. So if I differentiate y with respect to x, so the logarithm differentiation there will give us 1 over y times the derivative of y is 1. So we have times 1, then the y over the x, because that doesn't change anything. So equals, this is the multiplication law of differentiation. Also, let's talk about that. You have uv, you have a function, the product rule of function. The derivative of this function is the derivative of this, let's say with respect to x, will be u dv over the x plus v du over the x. So this is the formula we use whenever we encounter something like that. So I can say, let u be the cos x, and let the entire this, like this, equals to v. Okay. So if we do that, you can write it in this, following this formula here. You have u, that is cos x, and then the derivative of v, differentiating this, let's write that out. Derivative with respect to x of ln sine x. Okay, let's put that in the bracket. All right, then plus you have v, which is ln sine x, then the derivative of the cos x, which is u, that is cos x. Okay, so now this will give us 1 over y, will give us 1 over y, 1 over y dy all over the x equals to, let's bring this out. This is cos x. Differentiating, remember logarithmic differentiation again. So that will be equals to, permit me to enclose this in the curly bracket. You have 1 over sine x times the derivative of sine x is cos x. I enclose that. This is the derivative of this function here. All right, so then plus you have ln sine x, you have ln sine x, derivative of cos x is minus sine x. All right, then I will simplify this expression here. Just simplify it to make it neat by simplifying the expression. Simplifying the expression by the right hand side. Um, so if you do that, you will have 1 over y dy all over the x equals to, this is, I would not like this to match. So cos x times 1, you will have cos x and cos x over sine x, okay, plus this will be ln sine x and times, okay, so let me just bring this one at once to the back, because ln is a function on its own. So minus sine x times ln sine x, we change the sign from positive to negative. So that will be minus sine x ln sine x. Okay, I think we should call this equation 4. So we are almost at the end of the differentiation. So most times people allow this to be in the form cos square x all over sine x, but it's the same thing. So I would like to bring your mind back to different secondary trigonometric ratio, which says that cos x over sine x is the same thing as 1 all over tan x, which is the same thing as cos x. So I will substitute this place with that, and then it will become 1 over y, the y, all over the x equals to cos x and cos x minus sine x, natural logarithm sine x. Okay, we're almost there. So step 3, so 3 or 4, I. What I want to do there is I want to remove this reciprocal of 1 over y from this left-hand side, so that I will make the y, the x subject of the formula. So I'm going to multiply both sides by y. All right. So if we multiply both sides by y, we will have y times 1 over y dy all over the x equals to y into, what did we have there? Minus, okay, we have cos x, cot x, cos x, cot x, minus sine x, ln sine x. Let me confirm that. All right. Okay, that's true. All right. So close bracket. So by so doing, y will cancel y to have the y all over the x equals to y into cos x, cot x minus sine x, natural ln of sine x. Okay, so I would like to say recall that from the beginning, y was equal to sine x raised to the power of cos x. So we do the substitution into where we have y there in the expression. So we have the y over the x equals sine x cos x into cos x cot x minus sine x natural ln logarithm sine x. Okay, so this becomes the derivative of the function y equals to sine of exponential cos x. All right, so this is what I have to show you this evening. Is an interesting differentiation. I don't fail to subscribe to this channel. If not done that, just do that right now, because it's more and more stuff are coming up very soon. In our next class, I will show you how to integrate a very special function, integral from 5 to of this ln sine x. This function here is a special integral with respect to x. So don't fail to subscribe to this channel so that you will also benefit from the next class. All right. That's what I have to say. Don't fail to subscribe. I'll repeat myself. Don't fail to comment if you have any, and don't fail to like.